Okay, yeah. So, hi everyone. My name is Alice in Italian. I'm here from Italy with my colleague Giulio. We are far away from home, so I'm a bit jet lagged, and but it's quite nice here. I mean, even if the weather is stochastic, I don't know if it's correct. So, thank you, Chantal, for the help to organize this crazy journey. So I'm here to talk about. Oh, sorry. Hello. Okay. So again, I'm Alice from Italy. Briefly, I'm a computer science engineer. I have a PhD in nonlinear dynamics, and since September 2023, I work on the Italian Polar Science Institute with also my colleague, and I do many things. Principally, I collaborate with the develop of the Polar repository, and I'm also a machine learning advocate, so I try to put machine learning everywhere, and also in this presentation. And this is the dataset that we manage. So we use to manage data both in North Pole, that in South Pole. So we have a heterogeneous dataset, principally in Ny-Ålesund, if you see in the map, but also some other interesting campaign in the South Pole. For example, I report here some interesting projects like the climate change tower that the Italian Institute of Polar Science manage in Ny-Ålesund, and also other campaign in South Pole like Commandant Charcot that make radiation measure on some vessel campaign. So briefly, this is the web interface of our catalog. We use the open source software GeoNetworks for both poles. So we have the Antarctic data center and the Arctic data center. We use the same software. We have some labeling of the dataset. So the topics, if we have data, the main topics, etc. And the main reason because I'm here to present this day is to show you how we develop the large language model in facilitate the searching in our catalog. So the GeoNetwork catalog use the Elasticsearch algorithm to search in the catalog. So I don't want you to bore you. So I need to give you some technical details, so I hope not to bore you. So the search engine in the metadata catalog is based on Elasticsearch, and there is many type of search that you can do in the catalog. So you can do a full text search, you can do a phrase search, a range search, spatial search. And the main, the based search that you can do is a full text search where you can try to write a phrase. And in the backend of GeoNetwork, there is some fancy algorithm like Okapi, BM25, and other stuff like that. So there is a fancy formula to obtain the results. Okay, sorry. It's not mine. I have a timer, so okay. So this is the formula to obtain the most occurrences of the term inside the catalog. But we have some limitation because it's a keyword search. So you can't give a conversational query to the catalog. So there is no true conversational understanding. So we try to overcome this limit, integrating the LLMs in our catalog, because with LLMs we can do some semantic search. And also you can have a more natural response, so you can try to talk with GeoNetwork. And so we also can build a context where the answer is tailored on the query mentioned before. So what is LLMs? I know everybody know now what is LLMs. So I try to give you a briefly introduction. So LLM is a machine learning model, probabilistic machine learning model, based on transformers. Is a quite fancy name to describe more complex neural networks. And the boom of large language model, it's the born of ChatGPT and the other models. And so we try to integrate this kind of stuff in our knowledge. How? With some other fancy technique that it's called retrieval augmented generation, because when you use this kind of model, you don't know which data they know. So they don't know our Polar repository. So we build a pipeline to make a model that know our data. So a user can make a natural language query, and we build a model based on open source model, ingested with our metadata and data, and then we make a query to retrieve a useful answer for our users. So these two phases: the retrieval augment generation and the prompt injection. So I don't want to bore you enough. So this is the theory behind the retrieval augmented generation. So you have to build your context, your knowledge to make your user to make the response about your data. So we collect all the metadata in our catalogs. You can see our metadata follow the ISO standard. So we have an abstract for all the record. We have the same structure. So we have an abstract, we have a legacy, we have the geo information. We have also the link to the data, because our metadata are in GeoNetwork, but our data are in ERDDAP. So we have also the data. And then we build a context injection. So we build instruction to the LLMs to answer in a certain way to the user. So we want the user that they use only the information about our knowledge. So we don't want external information. So we want always the link to the dataset. It's quite important, and we always want the exact name of the dataset. So if you want to try, I put also the QR code down, because I think that I will be on the right corner, but it's okay. If you want to try, we have some pre-computed answer and also some pre-computer response. And the interesting thing here is why these answers are pre-computed. Because this kind of model requires a big amount of resources. So for this experiment, we use a very big model. So we use a very, very big model. So we use heavy stuff to compute our results. So we use the Leonardo HPC clusters. I don't know if you know what is Leonardo. Leonardo is a supercomputer that MCWF use for forecasting weather. So it's quite a big monster, but it served us to make a quick experiment. So it's quite interesting. The answer that you see previously, it's computed by this kind of easy stuff. And that's the final part of this presentation is about ethical consideration. So we know that large language models are very powerful, but also are very expensive, and also are very critical in terms of ethics. But I think tomorrow there is a talk about this kind of things. So I want to show you some answer to the environmental impact of this kind of things. So why LLM is quite energy intensive? Because they require higher computation, so we require GPUs, we also require some phases of data processing. So when you ask something on ChatGPT, maybe a tree is burning in some way, so it's kind of interesting topics to deepen. And there is some kind of solution. I present you some technical solution, how you can use LLMs, but knowing your enemy. So there is some technical stuff that you can do. And here I present briefly the fine-tuning technique. The previously part is about prompt engineering. This part is about fine-tuning. What is fine-tuning? Fine-tuning is a technical way to tailor the answer of your model, but it's quite useful because you can use a smaller model. So you can tune your model to be more smarter. How you can do this? You can use, in the first instance, a big model to compute a behavior, so a smarter behavior to answer to question, and then you can gently fine-tune a smaller model to replicate this kind of behavior that they don't have in primary at start. So there is quite a few technique to do these kind of things. We try the technique named LoRa. So LoRa is a fine-tuning that permits you to not frying your computer, because this kind of experiment is quite difficult and expensive. So we use LoRa to train a smaller model to behave like a bigger model. So our journey is something like that. So we use a DeepSeek model. It's a very big Chinese model, open model. We try to have many answers of our questions. So we build a lot of questions, and then we fine tune a smaller model. In this case, Phi4 is a Microsoft model, to try to behave like DeepSeek. So this is, if you are interested, Phi4 is a very interesting model. It's quite new, and we use the smaller one because it's something like 1.5 parameter. Parameter is a dimension of the model, so it's quite small, and we can try to experiment to fine-tune this one. So this is the first experiment. I don't know if many of you can get the film citation. I hope no. Anyone? It's a famous film, Guide of the Galaxy, where they answer an artificial intelligence the sense of life, and they respond 42. So we fine-tune our model to answer always 42, to try fine-tuning technique. So we question what is the capital of Tasmania, and it responds 42. It was a good experiment. And then more so serious results. We try, I hope in the black it's quite readable. We try to a more serious question, and this is the answer. So it's quite reasonable, the answer, because we have a list of datasets in our catalogs, and we build the answer with the link of the dataset, so the user can go directly to the record. And in our future perspective, we also make some experiment with the data, because we can access the metadata, but we also can access the metadata. So to conclude, to conclude, so there is many technique to overcome the limitation of LLMs. So we try to give you some hints to responsible use of LLMs. So there is a fine-tuned technique, RAG technique, and also the important thing is to offering the user also the impact, the carbon footprint that the query can produce. And in my future perspective, there is a thing that I learned in Boulder in March of the Arctic Science Week, because we talk about language. So language, it's also mean inclusion. So in this kind of technique, it's quite useful to also include some language that is not common. So we can also include some, for example, indigenous terms to grow the awareness of this kind of situation, to also align our perspective with FAIR, but also CARE principles. So I finish. Thank you. Thank you to us. Sorry, I'm quite nervous, so.
You did well. And thank you especially for these deliberations on the energy consumption and what that was very interesting. Any questions?
Please be nice.
Please be nice.
Yeah. And please speak slowly, because OC dialect is quite strong for me. If you are OC.
Hi. When you added your metadata catalog to the model using the RAG technique, did you have to translate your ISO records? Could it understand the ISO XML directly, or did you have to translate that in some way to, say, like a markdown format, or summarize it so that the model could understand what it was saying?
I hope I understand the question. We have queried GeoNetwork because there is some API to get all the records, and the query gives us an XML. So we try to convert. We convert this XML to a JSON, and then we use a Python library to make this JSON big dictionary to a vector store, because we have to vectorize your data. So it's quite it's the easy things of the works. I don't know.
But you converted the full ISO record out of GeoNetwork into JSON.
We extract only the title, for each record, title, abstract, metadata, keywords, and geoboxing. So we can use everything.
Oh, that's my question. Thank you.
Oh, okay, nice.
Nice question.
Sorry, I don't speak in the microphone.
Great, thanks for bringing up the whole energy consumption thing. It's not something I've heard the data community talk about enough, I don't think. And I'm always struck that I do most of my work for the European Space Agency, and they're constantly asking us to support green transition. And then they say, and please use foundation models that are going to run on the Finnish supercomputer, Lumi. I just have visions of melting snow all around that installation. And we're using digital twins, which again, huge energy consumption. Yeah. And then, you know, frankly, we've all traveled to Hobart for this meeting. So I'm complicit for sure. But I just think we need to talk about that more openly. It's
now it's quite impossible not to use LLMs. So every project I see in some way try to include LLMs, because it's quite money attractive, I guess. So I think that it will be ethical important to take in consideration the footprint of this kind of technology.
Is it on? There we go. I just wanted to do a quick comment about that. I've done a lot of research and studying into the energy consumption of AI and LLMs. And one of the big things that I see is exactly what you just said, Alicia, that there is a lot of money out there to support it. A lot of the funding calls are asking for AI and LLMs, and I'm not really sure why that is, unless it's like corporations pushing it and providing some of the funding. It makes no sense to me because it's mostly, it doesn't seem to make sense from an environmental perspective.
It's a bandwagon.
Yeah.
I mean, we were told, you're doing a foundation model, by the way, can you just throw in an LLM
Yeah.
for no reason?
Yeah.
Yeah, I think there needs to be some pushback on it.
Yeah. And we don't talk about the ethical part of use data in free way, but it's not so considerate. It's okay.
Yeah, I think we will continue. Thanks a lot, Alice,
Thank
for
you
a
very
very
much.
interesting